Good morning, ladies. It's Mr. O'Sullivan. Today we're going to be looking at Lesson 2-7, Parallel Lines Part 2, More Complex Problems. The reason why I call them more complex is because our visuals are going to be a little more complex. Just before we go into today's lesson, I just want to give you a heads up as to where we're heading for the rest of the week. Today is Monday. Tomorrow is Tuesday, which is election day. So tomorrow is actually fully remote for every single student at BYW. So instead of us covering new material, what we're going to do is we're going to have a work day. So the marking period is ending on Friday, so you're going to be working on your missing assignments. We do have a Zoom tomorrow. Please attend so we can check in for attendance, and if you have questions about specific assignments, we can work on them there. I'll be on the Zoom for the whole hour tomorrow. Wednesday, you're going to be having a quiz. So tomorrow I'm giving you a quiz review. It's totally optional. You don't have to do it. You should complete a question or a few questions. That way you're better prepared for the quiz. It's not going to be a long quiz, but the quiz will be your final grade for marking period number 1. All missing work needs to be handed in to myself by Friday at 5 p.m. That way I can spend my beautiful weekend grading your assignments. Yeah, so please hand in your missing assignments by 5 o'clock. That way I can grade them over the weekend, and I can submit grades early next week before parent-teacher conferences. And as always, if you have any questions about your standing in my class, please first consult Pupil Path, and then if you have any more specific questions, please email me, and we can set up a Zoom and discuss. Note, in a majority of today's problems, we're going to have to focus on extending our parallel lines, and remember that lines go on forever and ever and ever in both directions. Question number 1, you're going to notice doesn't have a visual, so we're going to have to create one. 2 parallel lines are cut by a transversal, so that's actually what I'm going to actually look at first. I'm not even going to read the rest of the question. I'm just going to draw that. So I have 2 parallel lines cut by a transversal. I know parallel lines are never going to intersect, so I'm going to draw 2 parallel lines. They don't have to be perfect. Remember, Mr. O'Sullivan does not have a bachelor's in art. He has a bachelor's in math. And now I'm going to draw my transversal, which is the line that intersects my 2 parallel lines to create my angle relationships. Okay. One of the interior angles on the same side of the transversal is 20 degrees more than the other. Find the measure of the larger angle. Well, I know I'm dealing with my interior angles. I'm dealing with my interior angle, so I'm going to focus on the inside. I don't know what one of them is, so I'm going to put an X on one of them. And I know my other interior angle on the same side is 20 more than it. So 20 more than is X plus 20. Because it's in relation to this angle, my other interior. Well, I want to find the measure of the larger angle, and we know that every time we do these, we actually have to figure out what our angle relationship is. So I know when dealing with same side interior angles, they are not congruent, they are supplementary, which means that they add up to 180 degrees. So what I'm going to do is set up my equation. X plus 20 equals 180. The first step in solving this equation is to combine your like terms. Well, x plus x is 2x, so I have 2x plus 20 equals 180. Now I need to get rid of my plus 20, so I'm going to subtract 20 from both sides. So I get 2x equals 160. And then my final step always is to divide by my number attached. So I'm going to divide both sides by 2. After dividing, I get x is equal to 80. But the question isn't asking you to find the value of x. It's asking you to find the measure of your larger angle. So if you're not 100% sure which one your larger angle is, just plug it into both. So if I plug x into here, it's just going to be 80. Now if I plug x into here, it's going to be 80 plus 20, which is 100. So 100 degrees is my larger angle. That's your final answer. That's the level of difficulty for the word problems you're going to be given. All right, let's begin the next example. Question number 2. In the figure below, AC is parallel to BD. Find the measure of angle A and find the measure of angle C. Remember, I said what we're going to do is focus on extending our parallel lines. So it says that AC is parallel to BD. So what I'm going to do is draw AC, make it a little longer, make BD a little longer. And what I'm going to do is extend my parallel lines. My transversal. So one thing that I know is that angles on the same line add up to 180 degrees. So this is 180 degrees. I already have 38 degrees and 67 degrees. So if I want to find out what goes right here, I have to do 180 minus 67 minus 38. When I do that on my calculator, I'm going to get 75 degrees. So I'm going to put that back into my image. And what I now know is that when I want to find my missing angles, we're going to focus on angle C right now. Let's find angle C. If I look at angle C, it's on the interior of my parallel lines, or my blue lines. It's on the interior, and it's alternate to my 67 degrees. So what I can say about angle C is that angle C is 67 degrees. So angle C is 67 degrees. And then if I wanted to, I can cheat. I'm going to erase my red line, or my red transversal. And now I'm going to extend my transversal at B. So let me make it red this time. And now if I look, I can say my 75 degree angle right here is alternate interior to this angle. So I have a 75 degree angle at angle A. So angle A is 75 degrees. Now let's go to our next example. I know that I have a 35 degree angle, so I want to find the measure of my numbered angles. I'm not saying that this is 1 degree, I'm saying that's angle 1. So what we're going to do right now is we're going to extend our parallel lines. This little arrow on it means that this line is parallel to this line, so I'm going to extend those lines. I'm going to use blue. And what I'm going to do is I'm going to extend this transversal down. So what I have right here now is I have a 35 degree angle that's on my interior, and I can put the 35 degree angle right here because alternate interior angles are congruent. I know angles on the same line add up to 180, so I can do 180 minus 35. What's 180 minus 35? 145 degrees. That's your final answer. Angle 1 equals 145 degrees. Now let's go on to our next example. This one's going to require our usage of vertical angles. If I look at my 112, I have a vertical angle, so vertical angle to here. So I have 112 degrees. I know angles on the same line add up to 180. So I have a 54 degree angle right here, so I can say 180 minus 54. 180 minus 54 is, let me figure it out in my head, 126 degrees. I know that this line is parallel to this line, so I'm going to put those in red. I'm going to extend my transversal in green. Ooh, and look, I have alternate interior angles right here. So I can say angle 2 is 54 degrees. And if I look, I have same side interior angles right here with my 112 and my angle 3. So I know same side interior angles are going to add up to 180 degrees. So I just do 180 minus 112. 180 minus 112 is 68 degrees. That's the value of angle 3. Now let's go on to this example. Ray RS is parallel to PQ. What is the measure of angle PRQ, and what is the measure of angle TRS? So this example is a little challenging, but it actually isn't all at the same time. The first thing we're going to do is extend our parallel line. So we're going to extend RS and PQ to see all the action happen. As you can see, we're extending our parallel lines. And what I'm going to do is I'm actually going to extend RQ now. If you look, I have alternate interior angles between my 3x plus 16 and my 5x. What I can do is I can set those equal to each other because I know alternate interior angles are congruent. So I'm going to do 3x plus 16 equals 5x. My goal is to get x's on one side and numbers on the other, so I'm going to subtract 3x from both sides. So I get 16 equals 2x. And then my next step is to divide by 2, so I'm going to divide by 2. Divide by 2, divide by 2. I get x equals 8. That's not my final answer. What I want to do is I want to find the value of angle TRS and the value of angle PRQ. So the first thing I'm going to do is find the value of PRQ, because that's what it asked me to find first. If I look at my visual, angle PRQ is, you start at P, go to R, end at Q. So it's my 11x plus 10. So I know angle PRQ equals 11x plus 10. We just said x was 8, so I'm going to substitute in an 8. And I get 11 times 8, which is 88 plus 10, so 98 degrees. That's the value of angle PRQ. I now want to find the value of angle TRS. Well, that's a little nifty. We're going to have to do a little extra work. Angle TRS is right here. I start at T, go to R, and at S. That's going to require me to find this angle as well. So I'm going to plug in my 8 into 3x plus 16. So 3x plus 16, 3 times 8 plus 16. 3 times 8 is 24, plus 16, which is 40. So this is a 40-degree angle. I also know that this was 98 degrees. I know angles on the same line must add up to 180 degrees. So this, I'm going to do it in black, it's going to be very messy, is going to add up to 180 degrees. So I already have my 98, I already have my 40, now I'm just missing my question mark. So I can just do 98 plus 40 plus x equals 180. I combine my like terms of 98 and 40. I get 138, so I get x plus 138 equals 180. My next step is to subtract 138 from both sides. So I get x is equal to 42 degrees. So I can say angle TRS is 42 degrees. And that's your final answer. And that's it for today. So this is an edPuzzle assignment. After completing your edPuzzle, complete your Delta Math, and make sure you're working on your missing assignments. Remember, you do have a quiz on Wednesday. If you have any questions, email myself or Miss Daniel, or attend Miss Daniel's extra help. Have a great day, ladies.